Have you ever found yourself gazing skyward, marveling at the sight of a gigantic airplane soaring overhead, and pondered, how does that colossal metal bird actually manage to fly? Well, the answer lies in a fascinating interplay of physics and engineering, brought to life in the form of aviation. Today, we demystify the magic of flight, breaking it down into simple, understandable steps. Firstly, it's important to understand the principle of lift, the invisible hand that keeps an airplane aloft. Lift is generated by the wings of the plane, or more specifically, their unique shape. The wings are designed in an airfoil shape, which is flat on the bottom and curved on the top. As the plane moves forward, air flows faster over the curved top surface and slower beneath. This difference in speed creates a pressure difference, with lower pressure above and higher pressure below. This pressure difference generates lift, which opposes gravity and enables the plane to rise into the sky. Next, let's talk about the driving force that propels the plane forward, the engines. Whether it's a jet engine or a propeller, the basic principle remains the same: sucking in air at the front, compressing it, combining it with fuel and igniting it. This process creates a forceful gust of hot air that thrusts the plane forward. This principle, known as thrust, works in accordance with Newton's third law of motion. For every action, there's an equal and opposite reaction. Now, for a plane to maneuver in the air, it uses a set of control surfaces on the wings and tail, known as ailerons, elevators, and rudders. The ailerons, located on the trailing edge of the wings, control the plane's roll, that is, its rotation around the front-to-back axis. The elevators attached to the tail control the pitch, or the up and down movement. Lastly, the rudder, also on the tail, manages the yaw, or the side-to-side movement. But what about the descent? How does a plane land? It's all about reducing both lift and thrust. Pilots lower the throttle to decrease thrust and adjust the wing flaps to alter the airfoil shape, thereby reducing lift. This combination allows the plane to descend gradually and safely towards the runway. To summarize, the magic of flight is a result of four fundamental forces: lift, which opposes gravity and allows the plane to rise; thrust, produced by the engines to propel the plane forward; drag, which resists the forward motion; and gravity, which pulls the plane towards the earth. The control surfaces on the wings and tail allow the plane to maneuver in the air, while adjustments to lift and thrust enable a safe landing. So the next time you see an airplane cutting through the clouds, you'll know it's not just a marvel of engineering, but also a testament to the laws of physics that govern our universe. It's a dance between man-made machines and natural forces, a symphony that plays out thousands of feet above us, every minute of every day. Now, isn't that something to marvel at?